Alright, welcome back. I'm excited because this is going to be the first proof we go through for the class. As you read in the syllabus, or maybe are aware, a big purpose of this course is to teach you how to prove things mathematically. So the very first one we're going to look at is for Theorem 2.1 here. And a lot of this looks very obvious. We know all of these facts when it comes to real numbers. We know, for example, that if a and b are numbers, then a plus b equals b plus a. Alright. But matrices aren't numbers. Matrices contain a lot of numbers, but we still need to make sure that all of these properties are true. So let's go ahead and prove property 1, which is similar to the statement above, but about matrices. So let's let A and B be matrices, and let's have them be the same size, so n by n matrices. Right? So this is a very important part of every proof, is defining the variables. So a and b are our variables here, and I've said that they are matrices of size m by n. And now you might say m and n are also variables that I have not defined, but there's sort of an implicit definition for them because it comes before the word matrices and it refers to a size. So they should be integers. So a and b are m by n matrices. Let's go ahead and write A is equal to A sub ij and B equal to B sub ij. So this is one of the ways we can refer to the entries in a matrix, where the entry in the ith row and jth column is this A sub ij. Alright, so again, row, column. Alright, so let's keep going. So we've rewritten that like that. So let's go ahead and let's just compute. So in general, when we want to do a proof with an equal sign like this a plus b equals b plus a, you want to start on one side, say a plus b, the left side, and you want to go through a bunch of steps to get to the other side. Alright, and you want those steps to have sort of a logical relationship with one another. So let's start with a plus b. Well, a is aij, as we just set up, and b is bij. Right? And the reason we did this is because we know matrix addition is defined in a way where adding two matrices is the matrix where each entry is the sum of those two. So let's erase this because we haven't gotten there yet. Alright, and now, so this is, let's see here, substitution in the first step. We want to justify every step. We did substitution, then we did definition of matrix addition. Alright, and now, at this point, these are real numbers. Aij and bij are real numbers. So this is because each entry is a real number. Okay, and we know that we can swap the order of real numbers when we're adding. We are trying to prove we can do the same for matrices. Alright, so now we can separate them again, bij plus aij. Alright, let's fill this in. It's definition again of matrix addition. Alright, and lastly, we can then substitute again. This is b plus a. Alright, and we did finally get to that right-hand side that we wanted to get to. So, alright, so therefore, a plus b equals b plus a as desired. Alright, and we put a little QED box, at the bottom to say we've finished our proof right there. All right, you'll find these boxes all over our textbook every time they prove something. All right. So that was proving property 1. You can imagine how property 2 would be proved, etc. Say property 5 might have a few more steps where you have to use the definition of matrix addition and the definition of scalar multiplication. All right, excellent. Thanks for watching. Have a good one.